as much stalling as I can do. Cool. So yeah, so kind of why GraphQL is good for the healthy teams. So kind of two parts of this. What is GraphQL? And then what are those ways of working that improves, what are the benefits outside of just technical reasons. So kind of really quick, who has never heard of GraphQL before? Cool, one person. A few people, cool. Who's heard of it but hasn't got a chance to use it yet? Cool, and who has used it yet? So that's actually pretty consistent with the rest of the industry. So thank you for confirming with that, that's great. So yeah, this is 2016, so a lot of people had heard of it, not many people had used it. People had used it, were still pretty satisfied with it, but it was kind of an emerging thing, it was still quite new. And then this year, it's kind of expanded way more than that as well, so loads of people want to learn how to use it. Again, not that many people have. I'm not sure why that is. I think people are kind of embedded into their sort of React Redux kind of world, and it seems a bit too new to use, but that's why I kind of want to share why we think it's really good, kind of how we push teams. So a bit of history where it came from. First what it is. So GraphQL is kind of three parts. It's a query language for APIs. It's a runtime to fill those queries. And it's also a description of your data, which you can do via schema. And it came from way back in 2012 with Facebook. So they developed this internal technology to use into their apps. So it's actually a lot older than people think it is, because it didn't actually come into full use until 2015. And it was only actually out of technical preview in 2016. So it's only really 2 years of full-on production ready use. And it is still evolving, so 2018 schema language was included in the spec for one time. So it's still kind of growing and changing things. That was only February this year. So I mentioned it kind of had three parts to it. So query language. This basically, rather than treating your data as resources, you treat all your data as a graph. So nodes, edges, entry points, that sort of stuff. You create a HTTP, but it is not RESTful. If you think it's going to act like REST does, you will have some odd surprises. There's also server-side runtime. So this is completely storage agnostic. You can get your data from anywhere. It can be a database, it can be other APIs. GraphQL doesn't care. There's a reference implementation available in JavaScript, but there's loads and loads of other implementations available in languages. The third part, which I think is probably the most powerful part of it, is just a type system. This is a strongly typed kind of schema that you write in a DSL called an SDL. It used to be called IDL. I can't remember the change that happened, but it's now SDL this week. So I'm going to jump through kind of these in order to kind of show you how they work. So if most people are kind of familiar with traditional REST, just the Pokemon API. So this will be your REST query to go get bulk sort, essentially. So you kind of get a lot of fields down, you kind of get what you're given the fields that are there. If you want to go get the related data, like abilities or stats, you have to go make multiple requests to go fetch that data. So if you can kind of go into the deep nested data, that's a lot of queries that's with all it. And a lot of people like this practice will version APIs. Because you can get what you're given, you can have to adapt over versions and make these fields in. And I don't want to bash on REST at all. REST is really good. It does what it does really well. But GraphQL tries to solve these pain points in a way that I think is really compelling. By the way, anyone, any questions, just raise it up, might be interested. So yeah, if you look at this query in GraphQL, you get something like this instead. So you get a single request and get multiple resources returned. You only select the fields that you care about, so rather than getting this sort of get what you're given approach, you say I want these fields back, and you get that back in your data structure. You can nest those questions down, you can traverse the graph back and forth, and then great schema. And there's some nice features like anything, input types, mutations, that sort of stuff. So I'm going to try to demo how this works in real time, it's a bit more useful. So this is a tool called GraphQL. Can everyone see that okay? Cool. So you can kind of build up queries with nice equipment. So I can go a bit data about this. Oh, it didn't reload on me. And you can see how the data I asked for is mirroring the data that's coming back. You can go to fields. You can kind of nest into this.
Can you make the font larger, please?
I'm sorry? Yeah, of course. Can you guys? Is that okay? Yeah, cool. That bit. So you can kind of see how this works. And you can do some nice stuff as well, like input variables, so I can name this query. Input variable, to what type it is. And then rather than kind of re-changing this query every single time, I can compile it down and just send it to some variables instead. you see how it changes each time. So the Pokemon, I know. So you can see how it changes each time you do the query. So you can kind of compile that top bit down and send the query over separately each time, which is really nice. So you can also do, as I mentioned, alias things. So say you want to go get another guy at the same time. So we get, I don't know. And we get an image each time because picture is awesome. You can see it can fail. Because the data structure comes back that mirrors your fields, you can't have multiple field names, so I can alias stuff and I can go. And again, you can see how that data structure follows through. So you kind of craft the data that comes back as well. You might notice there's a lot of auto completion on here, so if I do this, you get kind of a lot of schema moving. The way that works is that, as well as being sort of, you can query your data, you can also query GraphQL about itself. So every API has these sort of meta endpoints. So I can say, okay, tell me about yourself, and say what types are there, what fields are those types, what type are those fields, name of the, and I can kind of get that information about the API from itself. So it's self-queryable, it's kind of self-describing, which powers some really cool features like the auto-completion there, and you can get these really nice schema browsers where you can navigate through the data you've got, see what's available, get some descriptions in. So it kind of self-documents in a way that some of the APIs might be able to. So that's the basics for these GraphQL. Mutations are all the thing, but that's kind of how you query stuff. Cool. So the stuff that's built up from the schema that you could query, a lot is built by a lot of it's completely driven by the type system. So that looks like this. So essentially you have types with fields. You can have some basic scalar types like ID, strings, or booleans, that sort of stuff. You can have object types, which is what you use mostly, which are these kind of, say, names and types, like type Pokemon and whatnot. So they can be composed fields, they can self-reference, they can mesh with each other. You get mutations in types, and you also get a little bit of polymorphism with sort of interfaces and input types. You can do like a float or bool and that sort of stuff. So I'm also going to try and build on these up and use how to show you works, show some cool information. So this is a bit of a, see how it works. So there's a tool called GraphQL Fake, which I'm going to use today. So yeah. But you don't use this one. What this basically gives you is a sort of in-browser editor for your schema. So I can start to build up a schema. So I'm going to do one for the meetup group or meetup service. So if you type meetup, do that first. So meetup has a name, ID. So exclamation mark is a required field. Meetups have events, just an array of events. It can have an organizer. I'm not going to put Chris in, but person. So you can kind of define these types now and do person will have ID, a name, what's that stuff? Event will have an ID, pattern there, a name, and then you guys. Save that. But it will complain. So all GraphQL schemas have two kind of named reserved types, which are query and mutation. So these can be the entry points to your graph. So I can do query, I can do meetups. That will give me a list of meetups. Save that. And it's one thing as well. So you can also do your own scalar types. So I say event has a date. I can say it has to have a date. And I can say that's a new scalar. And you can do some nice validation rules on the scalar types to make sure you conform to what you think that should be. So the date could be year, month, date, and you have to validate that to come back. So that's cool, and I can actually now go and query this. So that's built an API for us. Not much use, because you just get these things back. Kind of cool to see the structure, but isn't really that useful. What Fake lets you do is stub out some nice stuff like this. So I can do meetup name. Person can have a fake full name. Event can have company BS doesn't work, unfortunately, so company cash flows what to do. Not sure what it comes out with, but I really want to find out. And a recent date. So I save that. You can see when I query this now, I get back some really cool representative data. So you can actually do this, stub out an entire API, build a front end on top of it, see how it works, not touch any of the back end service code. So it's a really powerful way to validate what you do. But if you actually want to say build out this into a useful thing, so resolving your own data, you have to use one runtime. So I've set up a really simple express server, so it just has a basic root on just register a route that will use this. That takes a schema, which we're going to create in a second. You can say use GraphQL. Use GraphQL is awesome. That will give you that sort of in-browser free, which is nice. So how do you build a schema? So you can do this in code. You kind of say, okay, these are my types and define them as an object. There's a few nice ways of doing it. So there's some tools that the Apollo guys have built, which they can pull in files and do some stuff with it. So we're going to use those instead because it's a lot quicker. So I can do. And we're also going to import this one, which is called Make Executable Schema. This is a tool from the Apollo guys, which kind of lets you make a schema and resolve it in the same place. So we'll do our type definitions. That's this file we did a few moments ago, or slightly earlier. We say that will go type definitions. And then we can make our schema with our type defs. And some results. So result is essentially just an object, so we're going to get blank object now. Export that. So we can now go to here, pull that in. This is all I'm getting as well, so I'll share links out later in case anyone wants to look at this a bit more over time. Cool, so that's been worked. Excellent. I should be able to go to our endpoint, get our GraphQL and query it. At the moment we've not written any resolvers, so that resolves it, just really nothing. So what does this look like? So essentially it's just an object, but what the object consists of is a set of types. Each of those types is an object, that's fields in it. So I can say meetups, and each of those fields takes a function that resolves to something. So all your resolves are functions. They can resolve from anywhere, any sort of storage, backend, another API. You can do whatever the hell you want with those. You can return promises, objects, whatever. So in this case, I'll just return an empty array. You can see when I Grice again, we get this back. Just to demonstrate this before, I've done a really basic sort of data structure here just to mirror the schema. So if I import this in, when I create this now, you can see everything's back. So you don't have to write resolves to every single field. If you have a data structure that mirrors your schema, in this case I've got name, I've got organizer, it will pull that data in just by looking at the object properties. So you don't have to do a load of work when it actually is a normalised data structure. But you see organizer is just an ID here, so if I want to go and pull through name, it's going to fail to resolve because it can't work out how to map that ID to something with those update type fields. So let's resolve it a bit nicer. So let's try and do that. So I've got some help functions here to this. So meetup's on the type, so I can find some results for that. Organizer, some stuff. It says find person. The first parameter function is the parent node, so in this case that's a meetup because that's what we're resolving it off. I say, okay, find person, meetup.organizer. Run this again. Cool, we've got some names. And you can do this for anything. So if I wanted to add a new field, so say I wanted to do member count, make it int. I don't have that data in my system anywhere, but I can just say, okay, well I can resolve it. So when I run this now, yeah, it's back. So you can kind of build up that schema and go from anywhere, come from data. And the nice thing as well, if I, instead of returning a straight number, if I return a promise, and make that promise be a bit slow. This works out. You can see it takes a long time to resolve that single field. But if I don't ask that field, it's instant, or it's the same speed as everything else. So it resolves all fields independently. If you have expensive fields, get those all the results, and not do it every single run. So where you have that get what you're given approach with REST, this lets you kind of hide away that expensive field data. So you're not kind of battering it by having new fields API. It lets you kind of be a bit more adaptable. Cool. Any questions things we want to see on kind of how it works or not? Cool. So yeah, that's essentially how you build a bit of Go. So hopefully that gives an idea of what kind of GraphQL is, how it works, how you get started with it. But I said at the start that it's not just technical reasons we enjoy it, and it's kind of improved how we work as teams as well. So how to do that? To me, there's four big ways. So the first biggest one is that we're now kind of doing what we call schema-first development. So we work in agile fashion at Sainsbury's. We do user stories, we do data standards and SOs, all that sort of stuff. We break down these tasks. The first task we end up making in pretty much every story now is this one. We have a schema task at the very start. So we've kind of done stuff like this before with sort of JSON API or Swagger, but those tend to be kind of how we build this thing, kind of how we're going to get the data stuff. What this tends to make you think about is it makes you model your business domain as a graph. So it makes you think about nodes and edges, how the data relates to each other, how you enter that graph, how you traverse that graph. It makes you think about it in a much more kind of holistic fashion. It kind of makes you think about how clients need to use their data rather than how best am I going to provide that data. How do they want, what do they want to have data, how are they going to use it, how are they best going to present it. So you can kind of tie that data representation a lot closer to your clients and how they care about it. So the GitHub have a GraphQL endpoint. In kind of the rest of the world, you might see this repository pattern where you go, okay, we across the field, we'll do like an is starred, is pinned, and kind of overload all that stuff. But in GraphQL, because you only get what you ask for, you can kind of just get away from that way of doing things. You have starred repositories, pinned repositories, whatever you want. If you don't ask for it, you don't get it back. So you can kind of make it much more close to how you can use it rather than how you need to search it. Rather than like clients using it rather than optimizing it for a developer or optimize performance. So you kind of start thinking about what instead of how, which is quite a nice way to think about it, I think. What do my clients need rather than how we build it. The second biggest benefit for me is that it tends to decouple your front end and back end, if they're not the same people, but your time spent. So a lot of front end developers in the room, I'm assuming you've heard this before, where you build a thing and you go, okay, well it's working, but we can't wait to hook it up to something, or we're waiting for some API to build or an endpoint, or we just go build it ourselves. GraphQL kind of tries to get away from that and they kind of decouple it a bit. So where you've probably before built that and check and forth and iterate and work out what's going back and forth to back end and front end teams. First thing we do now is build a schema, and that's done as a whole team. But after that point, the back end team will often build some resolvers from API, front end can build a UI for it, and you can kind of test that against different bits. So you can use contract tests to test your API against your defined schema. You can use the GraphQL fake stuff to check it against an actual working API that is just stubbed out. And then that can deploy wherever it wants, when it can deploy whenever that those fields are available. So it kind of lets you just work in isolation a little bit, as well as making sure what you're going to work on kind of conforms to an agreed principle. It's some weird thing that makes you work in isolation, but it lets you collaborate more on what you think the data representation should be, and then both build a function that matches that. And there's lots of ways to kind of avoid this. So you can mock out a guide for Faker, you can do contract testing with this repo here. If you have new types added to a schema, you don't have to care about when you release, you can just push them live. There's no clients using them, so you don't have to care. Nothing's going to break. And if you're adding new types or changing stuff, just you can deprecate the old one. Add a new field, release out. This old stuff will still work, it's still resolved the same way. It lets you release a lot faster and can get things out without having to wait for things to catch up. I think Facebook stats, when they first built it, they had a rolling 2-week releases on their clients, so like their Facebook, their mobile apps. They supported every single release for 2 years. So at any one point they had 52 different versions of their clients sitting around and needing to be supported by APIs. So let them do that. We're not quite at that level, but it lets you support that a little bit. And a lot like it's a lot more flexibility. So the fact there's no versioning means rather than having to kind of like rubber stamp each version, make sure it's agreed, make sure it's communicated out, you have to transition from your clients to a new version. You can kind of just grow that graph and sort of slowly adapt it, add new fields as you need to, move kind of in a more adaptive fashion. We found it makes feature flagging a lot easier because you're not requesting the fields on the branches that are flagged off. It's not going to add any extra load stuff, it's not going to add any more complexity, it's more asking the fields. So you can just keep them in the way until you need them. And also, we've not done this yet, but I've heard some people have. Because you're asking for fields only when you need them, it is possible to do some analysis on those. You can say, okay, someone's resolving this field a lot. We'll track who's resolving what field and when. You can sort of see what parts of your platform are being used more by different people. So you can say, okay, well this everyone's using this, no one's using this, maybe we need to adapt our way to spend that time. It's probably more useful for platform devs than it is for application developers, but it's still a really cool thing you can do. And the last thing for me, which is more of a, I guess, organisational level benefit than a team level benefit, is that I think it's really easy to adapt. I don't know why, so the size of the start, that it's quite a big barrier to people wanting to use it. I'm not sure what the reasons are behind that, but I found it really easy to get started with. There's loads of language support, so JavaScript is kind of like the reference implementation, but there's loads of different implementations go for runtime. We use the PHP one, which is quite nice. I know the Scala one's very nice. I'm not using the rest, but they're kind of all similar planet. And that's great if you're building new stuff, but if you're building existing stuff, there's nothing stopping you from wrapping what you've got. So if you've got a legacy API, some third-party stuff, maybe something in MongoDB or SQL somewhere, you can quite happily just stick a JSON implementation wrapper in front of it. Resolve some fields from one API, some fields from your storage. Because they're just functions, you can do whatever you want with it. Build an app in front of it, and you've got essentially from this kind of disparate set of services, kind of shared language. So one API might talk about some sort of part of your business domain in one way, or another way. You can build this shared schema that lets your service and apps talk about everything in a similar way, resolve things in a similar way, and get data from back. And lets you experiment really well as well. So there's tools like GraphQL or Prisma, which basically take a schema to annotations and will build you a fully functioning CRUD-based like GraphQL API. So you can do mutations, you can inputs, you can filter, all that sort of nice stuff. And they have sort of hosted solutions, so you can spin something up in about 5 minutes and have a working API. It's fantastic. Stick that in front of that and off you go. GraphQL Fake is awesome, and if you want to kind of do something really custom, you can just lock your own resolves and roll your custom data. So you can kind of really play around with it and see what you get before you have to kind of commit to a full service. So yeah, I think GraphQL is awesome, as you might have gathered. I think it lets you be more flexible. I think it lets you work together